Okay, so staying with the Tool Vise, items 5 and 6 are similar. They are surface is flat, otherwise parts 5 and 6 are identical. That notation tells me that I can make one part. And then I'm at a decision point of, do I save as copy and save as, what's the other one? Save as copy and continue. And then the other option is to make this a configuration. So on the manufacturing side, since I'm looking at this with the design for manufacturing in mind, this kind of back-angled face, the 25 by 0.063, we're going to see what kind of pocket we can generate in there and still achieve the same functionality, but lose a setup, basically, that has to tilt that back over the angle to relieve probably a 45. Well, it's 0.25, just shy, so 40-degree angle that I'd have to fixture for and have kind of at a compound. All right, so I'm going to instead make that a little pocket so you still have that relief, and see what kind of radiuses we can put in there. What's in cold rolled steel, if I could get a 16th, which would be a 30,000ths radius, that would be, I think that would be pretty good. Maybe a 3/32, which would be a 047, 048. That would be a reasonable as well. The other side of it is still are we making one to replace tooling, or are we going to tool up and go into production on these things? So if we're going into production, then getting it into the assembly, getting it through the full manufacturing kind of evaluation analysis, that's going to start to reveal some of those. How much do I want to fixture? What size stock are we going to work from? Is some of this going to be better off in a stamping process? All right, 1/4 inch cold rolled steel, probably not, but still the questions are out there. So looking at the part, it's pretty straightforward. The pins were called out as drill in the assembly. I think with the CNC and tolerances and a little bit of the drill and ream, I think we can hold the positional to go ahead and include those, as opposed to having a secondary operation on a finished assembly. So if I have to press those in or even put a little green Loctite on it, I'm okay with it holding that position, being able to make sure that those are in alignment for the scale. All right, so for the mentioned earlier, the scale protractor I've been working on, protractor scale I've been working on offline, trying to get the marks to follow the sheet metal around. The wrap isn't really a good option. I'm sort of tempted to go to a decal, but at the end, I want to be able to make these if this Brown and Sharp Brown and Sharp gauge is no longer available. Right, so I want to have a secondary plan that I can machine to. All right, so I've got the tick marks following the arc around, and when I get a better strategy, we're going to revisit that one, because it does take some a little bit of computing power to get all of that geometry to follow that radius around the protractor. So interesting piece. It's always the ones that look the simplest that end up fighting the hardest. So. All right, so I've been saying that I want to change this background. I'm not fond of the gradient, so we will find that under the scenes, and under the basic scenes, I'm going to scroll down until I find the plain white. Right-click on the plain white, and that is going to set as default scene. All right, so once that's the default scene, now that will be listed. Let's see, which one is it? Plain white. That is now the default, and I lose the gradient. And if I need the gradient for whatever reason, for demonstration or just because, we can cycle through those scene backgrounds and make that adjustment. But I like kind of a minimalist background where there's not a lot of extra things going on. All right, so my heads-up display got shifted down because I added surfaces last time, so I'm going to turn that one off till I need it again. And so one of the things that you're going to do on a regular basis is just manage your work area. If you have 29-inch plus monitors, then chances are you're not going to have a lot of issues. But you know, 20, 24, 27 in that area. This one, the resolution was shrunk down so that I could get it into the video. So I'm working in kind of that condensed laptop scale. So, all right, oops, wrong one. Didn't need to measure anything. Don't have anything to measure. So going into the sketch for this, pretty much where I see symmetry, I want to use it. So vertical, infinite length, and symmetry means center line. All right, so I'm going to draw half of this this geometry. So up, over, a little bit of an angle, come across on the flat. So on whether I go to the save as copy and continue, generate a configuration, I want to pick kind of the most common elements in this geometry. So let me jump back over to this one. And between these two pieces, other than the call out for the flat, this arc I can add in separately. And I may just want to put a small relief for the screw that's going to be in clearance on. So all of the rest of the geometry is in place. It's just a matter of adding that one last item. So that being the case, I want to pretty much build this one and then add that geometry at the last. All right, so we have the up and over, go ahead with the mirror, and our overall dimension 3.5, and we'll let the auto scale do its thing. Overall height is 0.75, so going between the object lines. Let's see, we have 0.75 on the end face, end angle, and 0.562. And again, more out of habit, I'm going to carry that out. And the rounding, we have to make a decision on the rounding under our units. I don't really want to jump into that until I finish the sketch. But under the units, I can tell this to round up, round down, pretty much whichever I want it to go with it. So the 5625 rounds up to 563, even though the drawing is calling it as 562. I'm not concerned about that number. All right, so let's see. I'm going to add the notch as a separate geometry. We can go ahead with the slot though, and under the slot we have a 3-point arc slot and a center point arc slot. So in this case, I'm going to go with the center point, pick its location on the center line, and then we're going to drag the arc. Well, nothing really happens until I move cursor again. I move the arrow. And once I give it a size, then I'll have something a little closer to what I'm looking for. All right, so the center point gets coincident to the center line. And we have 16 degrees off of either side. So let's see, I can either go with another center line, or we can use the vertex. Let me drop in the 2-inch from the base to get that set. So rather than adding in additional construction geometry, I can use a 3-point angle. So that angle is on the dimension is set up as pick the vertex, pick one endpoint, pick the other endpoint, and it will switch to angle and allow you to place that geometry as if there were construction lines, as if there was additional. Let's see, we have a radius of 1 11/16, 1.6875. And let's see, the radius, no, and the thickness, if we go between the two arcs, 0.265. So we have some clearance there to work with. All right, so I don't want to get any more complicated on this particular sketch. So we'll go ahead and extrude. Give it the 0.25. And go ahead and accept. All right, so the other hole locations, those can be for the hole wizard. So S key, pick out the hole wizard. I'm going to do the counterbores first, and this is going to be for a. See, make sure I've got the counterbore selected, and we'll try the Philister, see what it ends up as, but pretty much a 1/4 inch normal fit. If we show this custom sizing, we're given a call out, and this one's going to be a little bit tighter. So 266, 453. And that's not looking very close. See the binding head screw, 266, 562, no. Alright, so if I look down through these, numbers really aren't jumping out. Alright, so a little bit on the large side all the way around. So let's see what a socketed cap screw looks like. That one's a little bit closer. And so there's definitely a larger clearance back to the 1/4 20, and I just don't see that as needing to be that tight. So if I go up to loose, it goes to the 281. Counterbore stays at 7/16. If we override one of these, 0.406, it's going to turn yellow, but other than that, it's just more of a warning that that geometry was in place. So also the depth goes to 5/32, 0.15625 if we carry it out. All right, so through all on the hole, no head clearance, side clearances, and we'll go into position. I'm going to go ahead with the center line and mirror across so we can utilize that geometry. 3 inches between centers, and lost something somewhere. Yep, so I told it to mirror. There we go. That looks okay. Three inches, and then 281 from the base. Okay, so those are good. All right, so 1/8 inch, 3 times 120, and then ream to 125. So put in the simple hole. Let's reset for the new hole type. If we were doing a bunch of these, then I would go ahead and let it keep it, but want to be careful with the defaults, so we come back to those standards. Okay, so I know it's in there somewhere. Let's go to fractional. 1/8 inch. Through all is okay. We'll pick up the position. Alright, so between the two. Alright, so I didn't mirror those. I'm going to set up symmetry by putting in the center line. And then control select the point, the center line, and the other point, make symmetric. Let's see, we have a distance of 3/16 from the base, so 0.1875. And it gave us 2.25 between the centers. All right, there's an additional point, so we'll clear out of that, place one more point, and it is 1/8 of an inch up and 0.75 off of the center line. Oh, missed something there. Okay, so that's the pin that basically acts like the stop. Okay, so in this case I want to identify somewhere in there. Identify a dimension, and then we're going to set that to 4 decimal places. Okay, so we have our geometry in. We're going to work on the relief next. So let's take another look at that. Have the 90 degrees, 2 inches off of vertical, which is kind of a weird way to dimension that, but depending on what we end up doing for the machining, it shouldn't be too bad. So. Alright, so we're going to pick up that geometry, and I would like to go ahead and put a point. See if we can find it. We'll put a point at the center so that it goes defined. I have that for reference, and then we're going to come off of that face. Now let's see, it does come off back to that face. And those are going to be perpendicular, so we'll add that relation in. Now for location, that one's open to interpretation. That's always a good time. So the hole at the center looks like that angle, but usually when I make those assumptions I get myself in trouble. So we'll go with that, but that's going to be another one of those items we're going to have to double check out of the assembly. So that being the case, let's show the sketch for the hole wizard. Make those vertical, and actually tying that to a relation probably isn't the best way to go. So I'm going to take that out and go back to the dimension, which we can go between the origin and then 225 divided by 2, 1.125. Now let's see what we get. 2 inches off of center line. So I'm not seeing the other dimension. So on the other piece, there's a 40-degree dimension, but I'm not sure what that's sitting in relation to. 40 degrees to the first angle. Alright, so this is basically going to be the alignment back to that face. So we'll try another, no, I'm going to need the center line. Alright, so let's get that in for reference as far as its location. And then just to quickly close it off so we can make the cut. And then that'll be a cut, let's see, 0.25, we end up 0.062 or 0.063, so that'll give us a 0.1875 3/16 depth of cut. I almost want to have that small V in there first, but alright, well, we'll see what that gets us. So I'm going to convert a couple of entities into the geometry, or into the sketch. And with converted entities, we're picking up those edges, but then I can pull it back because it's not really defined. Add in the other line. Go ahead and make those parallel. And then well, maybe let's see. Find that center point again. And even if this ends up being a driven dimension, no, we're still at the 40 degrees. I'll have it for reference. Now 15 degrees on that arc, up and over, but it doesn't really pick out those locations. So equal divisions calibrated in the assembly. I'd like to be a little more precise than that. So let's pick a number. Alright, so if I were to make that 0.25, which was the length of the angle, and so instead of having this come over from that face back, we're just going to go right to that that edge and give it a through all ended condition. Alright, so generated more questions than I would have liked, but let's see what we can do with the radiuses. Alright, so I would like to machine this with the same tool, and that fillet will pick up. So considering that's a 100 thousandths radius and it looks pretty generous, I should be able to get a 3/16 in there, so 93.75 if we're carrying it out, and have enough clearance. Or we go with an 1/8 inch, 0.0625. So 1/8 inch diameter cutter would go in, make that relief, and we see what that would what that'll look like in the assembly. 1/8 inch over the corners. Alright, so simplified some geometry, may have made it more complicated on the other end. So let's go ahead and save. Tool Vise. This is item 5, item 6, the lower plate. Okay, and because the upper plate just has that additional geometry, this is where we make that choice of going into a configuration or doing a file save as. So initially, you're going to save as. Save as a copy and continue allows you to keep working on this file. Save as copy and open says open the new file and under the new name. All right, so we're going to change that over to item 5, upper plate, and hit save. And what I want to check for is that in my title bar, it actually switched over to item 5, upper plate. So now I'm making sure that on the feature tree, on the title bar, that I am modifying the correct part, not the original. Okay, so I'm going to pick up that center point. Not overly concerned with this being a circle. We'll go with the radius 1.375. Well, I'm in the circle, so 1.375 times 2. All right, so 2.75. If I want that to read as a radial, then I'm going to go back to the liters, and we're going to switch it from diametral over to a radial dimension. And then this can extrude cut through all. All right, so for 2 pieces, the save as copy, and continue, or save as copy and open, save as copy and continue are not going to be that big of a deal. Where configurations would come in is we are doing 3 different sizes of this vise, and I'm going to have then 6 total parts that I'm going to have to work with and manage. So in that case, I'd want to consider generating a configuration. But for now, that will suffice. All right, like to have the fillets at the end. So I'm going to go ahead and reorder the cut extrude just by dragging it. Left click, hold down, drag it, and reorder the feature. All right, so did I miss anything? All right, so need to verify geometry. We're going to tie that in back into the assembly, and we're ready to go on to the other items. Okay, so the upper compound looks like an arc over to the flat, reference line 3 required. So unless they're talking about the extension line, I see one there, one there. Not sure where the third one is. Yeah, so maybe we can figure that out. No, not in the same locations. Okay, so distance length, that ought to reveal what the height of the flat is. Got the clearances, so yeah, let's go ahead with the next part. All right, so both of the those plates were left open. File new, part inch, front plane. Generate a line. Go ahead and make it for the midpoint to get our symmetry established. We have a distance of 3.5. bring that down a little bit. And then really those can be equal, just so that I don't get any strange movement when I'm applying the arc. So if we go with the center point arc, sweep it through. Missed the end point, but there we go. Alright, so overall, we have to just go ahead and set the dimension for the arc. We're back into the leaders, and under the leaders, I want to make sure that I'm picking up a min or max condition depending on what we saw in the arc. Let's see, why is this underdefined? Let's go back to the center point, make that vertical. And we had the overall height. Let's see, that was a radius of 2 inches. There we go, radius of 2 inches. Yeah, reversed itself. That's nice. Oh, I guess it would help to have the correct dimension in here. All right, so overall 1.132 to 1.118. So let's go with the maximum material condition, and we'll set it at 1.132 as the high end, and then we'll give it a minus 14. So let's go ahead with a let's see, that was a limit dimension, and we're going to set it for, I can stay with 3 decimal places, minus 14 thousandths. Alright, so when we're doing the tolerance analysis, I really want to see that larger number, and then we'll see where it ends up in the mean. Alright, so that one needs to be marked for the drawing. And what else do we need to put on this? I think that's good for geometry. Let's go ahead and expand that out. 3.498. Also a limit dimension. Alright, and because I was using the mid planes, we're going to stay with the mid plane so that I'll have the front or the right plane bisecting the part. And that gives me the geometry. All right, so for that that distance, then let's go ahead and make it a limit, and it's going to have a minus of 5 thousandths. Okay, and then one more is to double check. Nope. We're going to right click and also mark for drawing. Alright, so at some point I want to save this, so I'm going to go ahead with 3 upper compound. Alright, so in the center, nice thing about doing the midplane is the origin remains. Let's see, our maximum material condition being the smaller number, 1.999. And back into the limit. Upper number is 002, so 0.003 on the tolerance. And then mark that for drawing. So that one will get it an extruded cut, and it's going 9/16, 5625 in depth. Alright, so let's look at the call out for some of these threaded holes. Alright, so that was at center, that's at center. Distance, overall height. Alright, so it goes through. So looking at the geometry on the, well, what are we calling this now? The actual tool holder. Looking at that undercut geometry, that very first plug that we did with the angle, it's going to engage. So if they chose stock for a 3/8/16, the tap drill should be right there at 5/16. Surprised that isn't a little bit tighter, but yeah, we'll see what it looks like. And then let's see, as far as length, if we're going through and then to a drill point, no, that is the tap drill. So wherever the tap terminates. All right, well, go into the S key, pick up the hole wizard. Going to set the tapped hole, and its dimension was 281 off of the top. So let's see, ANSI inch. This one's going to just be tapped hole. Scroll until we find the 3/8/16. And through all, this is one of those instances where we want to use up to next so that it stops at this inside wall. Right. The in condition of the hole, but the thread, we're going to stop at 9/16. Okay, and then go in and set the position. Go for a vertical dimension, 281, and the 9/32 is actually 281.25, but we'll bypass that one. And go ahead and accept. On the opposite side then, hit the S key, pick up the positions, we'll go normal 2. It's not really showing, so I'm going to go to hidden lines, and then I can pick up the opposite. Alright, so on the hole wizard I've got that one still, oh I didn't adjust that one. So back into the hole wizard, and 0.563, so that we have that thread. Alright. Next one, back into the hole wizard, and stay in the hidden lines visible. And this is going to be a reamed hole. So for a 5/16, basically the tolerance that I'm looking at, the 0.3125, 0.3135. We want to be, let's see, we're still in the cold rolled steel, so we'd want to be anywhere from 5 to 10 thousandths undersize. So we need to find a drill size that will get us there, and then put the ream over top of that if we're going to call it out to that level of detail. So on the drill sizes, let's go ahead and show the decimal values, and then scroll down. So 3/10 is a little bit close. 0.03. Let's go up another decimal. 296 is pretty 10 thousandths on the end drill. Yeah, I think I can work with that one as a starter point. All right, so position. Going to set it to be vertical, and then from the top, 811 to 813. All right, so when we have that kind of call out, I'm going to go to the mean 0.812. All right, basically that's where I'd like it to hit positionally. I'm not concerned maximum material condition for that number, but positionally I'd like that one to be at the mean value. So 0.812, and when we do the tolerance for it, it's still going to be a limit dimension, but both are going to get 0.001. So that gives me my range of values, and the issue there is kind of the functional gauging of how do I measure where that whole location actually ended up, except to put it into the assembly and does it work, or we put it on a CMM and see where the geometry comes out. All right, so for the actual ream then, oh, I didn't set a depth. Oh, went all the way through. That was nice. A little too deep, but okay. So let's see, end condition, go with blind end condition. They called it out as 11/16 for the depth. I'm going to go a little deeper, and let's go to back to the 812 on its position. I'll go back to the other side. S key, whole wizard. All of the values should be the same. Back into the positions, and because I'm still in the hidden lines visible, pick up that center point. And if we look at it from the side, I'm going to see the two drill points at depth. So let's see, concern? No, that'll make the clearance. So. Right, so let's go back in and pick up the ream tool then. 3125. Blind in condition 0.6875. Well, putting 4 decimal places on a ream like that, unless we are going to bore, I don't know. I have oh, I picked up the thread. That still needed to be a simple hole. 5/16. Oh, nope, that's not 6875. And it's rounding for me, so there we go. And back to position. And what I'm looking for is on that side view, hidden line, we have just a little bit of relief there for the ream. Okay, back into positions and location. Alright, so let's go ahead and save. Let's see, what other geometry? Okay, so apparently this drawing is old enough that the G on the faces are going to be the grind marks. So we'd want to put a surface finish mark there. Interesting that they're calling it out for chrome plate and then doing the engraving. So it's either really thin chrome plate or, well, it's just going to fill up the engraving. So maybe we'll black oxide that instead. Not sure what for the tooling. We'll pick something up there though. All right, so we have the same issue that we did for the scale. I need to start that base geometry, and for the machining, if I'm just doing engraving, I want this to be single point geometry. We're not really going to have end mills small enough to go in and hit all of those lines. So I want to get a decent representation, but I want to keep the text fairly simple, keep the geometry fairly simple. All right, so let's set up for the center line. Go vertical, infinite length. Set it to the origin, and that is at 40 degrees. Okay, and if it's pointed back to the center of the circle, well, let's go ahead and pick up that location. Okay, so the line and the center point go to coincidence. And we're going to make the 0 tick mark 1/8 of an inch. And then the smaller tick marks will be 3/32. Okay, so coincident to the edge. Doesn't look like it got coincident to the center mark. And those are in 1 degree increments. Okay, so we will round that one to 94. And see how much trouble I can get into with a circular pattern on this one. So let's see, we need, well, we're going to 15 degrees, so we need 3 of these. Well, accumulating up those patterns last time didn't really help, so. All right, so back to coincident. So we're going to have the 4 intermediate lines and another long. So equal, equal, equal. One more. And then one more long. Okay, so coincident there. Coincident there. And coincident there. And since that one, well, maybe I didn't want that one to be coincident. Okay, make sure that I have the separation. Okay. All right, so we can go 1 degree in between each mark, or 1, 2, 3, 4, 5. I think it's about as easy to go 1 degree. Yeah, so something picked up parallel? No? Well, I did pick up parallel, so that one goes. Nope, still not what I was looking for. All right, so let's try the coincident back to the center point again. Set those to equal. Set one more 1 degree. All right, and now I have the 4 pieces that I need for the circular pattern. All right, so points back to the origin, and that point we're going to remove and go to the center of the arc. All right, and then we're going in 5-degree increments, so instead of equal spacing all the way around, we're going to give it a total spacing of 15 degrees. Okay, 5-degree increments with a total of 3. No instances to skip. We have all the entities pattern. My recommendation, if you find that you need to skip something to eliminate it on a pattern, is go ahead and leave it, and then take that one and convert it to construction geometry, so that it's still there, it's still available, even if it is not being shown. All right, so my 2 guesses here. Nope, not that one. All right, so with the center marks, or the tick marks. All right, so got to move something and see what it's doing. We'll get that back to center. I took one of the endpoints, made it coincident with the outside edge. That should give it the geometry. All right, so let's count 0, 5, 10, 15. And to get the alignment for the text, we're going to need to set up some more construction. So let's rotate that over, holding down the Alt button and hitting the arrow keys. That's going to put it in a little better alignment. Want the numbers kind of to follow that arc. So in this sketch, we're going to create a center line and bring it out collinear to one of the tip marks, perpendicular back to that one. And not sure what size text I'm going to use, so we're just going to take a guess. I want to leave, well, so the lines don't blend. 16th looks good. 62. And the length, yeah, 1/8 of an inch, 0.12 should be pretty good. All right, so what this is going to do is give me a curve to reference the text to. So if that's pre-selected and I go into the text, the decision that I need to make, and this is going to be 0, 0, and I'm going to set it to center justification. But if I'm engraving, the engraving tool will come in, make a single pass. When it comes to the 0, though, it will make 2 passes. So I either need to find a single text, well, let's see, how can I do that? Turn the document font on, select the font button, and let's see if it's in here. All right, so we'll have to either go find a single line. No, I'm not seeing any of it. Or the CAM package that I use, CamWorks, has an engraving that that is, even though it's a TrueType font, it still shows as a single line geometry. So make it an 1/8 inch tall, see what it looks like, and that kind of goes to that. All right, so we lost the two paths going around the part. All right, so center line. Perpendicular, go to midpoint. We'll set that to equal, and those two center lines to equal. Pick the next center line, open up another text, and then this one goes to 5. Oh, not percentage, 5. Still in document font, and my record button is right over top of that, which makes it kind of annoying. So use document font, no. Go back into Cam, and I will search around, see if there's other single point fonts. Those may be a little on the large side, especially when I get into the double digits. Alright, so back to the midpoint, set to equal, pick the line, go to the font, number 10. I would stretch that out and that's one. It'd be nice if it stayed. That's a little more shift than I would have liked. Let's see what it looks like if left justify. That one's not really aligning. Okay, so we'll have to figure out how to make that shift or make it smaller. And we'll do one more and see if wrap this up. Alright, so select, control select, let's get that in there. Oh, go linear, go back to the midpoint, set to equal, and set to equal. Pick the curve, go into the text, 5. Alright, so same basic process. And those are going to have to shrink a little bit, and I'm going to have to come up with a better way to shift than midpoint. It's okay on the 0 and the 5, but the double digits aren't playing well. Alright, so that being the case, we're going to take the midpoint off, go back and make it coincident. So dimension, all those were set to equal still, so we just need to give it a shift. And I'm pretty much going to have to make them smaller too. Where did my midpoint go? Okay, so same shift. Okay, maybe not that much. Oh, that was where we were at. All right, so to get back into the text to make that that adjustment, back into the font, let's go with 100 thousandths and accept the sketch, or accept the text. Back to the font, and accept this text. All right, so looks a little better. And I'll go ahead and accept. So if I've done that correctly, I should be able to. Text isn't going to go fully defined, so I'm not worried about the minus. So if we go ahead with a rename, let's see, that can be the tick marks, and then sketch 16 will be the numbers. Alright, so what'll be interesting then is if I take the tick marks and do a Control C, pick that face and do a Control V. Well, got close. Alright, so editing, we'll see how much cooperation. No, not that much. If it kept most of the pattern though. Yeah. Well, not really. I mean, it's kind of one of those. Well, they're going in 3, so I only have to do it the 4 times. To do the Control Select and pull it up, I think it would want to make them coincident to each other as well to that edge. So one at a time, I'm gonna take what I can get and call it good. All right, and it picked up the existing center from the other ones, so we'll just make that coincident so it's there. All right, so that was relatively painless. Go ahead and save. The numbers, let's see, this one probably needs a, let's just put an F on the, for the front, and we'll put a B for the ones on the back. Numbers, I suspect, are going to be about the same. Control C, Control V. All right, so kind of wherever you place, that's where they're going to get. So numbers B, and we'll go ahead and edit. Linear. So if I was doing this for a lot, I would come up. I'd want to come up with a better strategy. Now from the programming side, because since these are on technically it would be in the same orientation, opposite sides. I really would only need the one, but for illustration, for detail, need to pull up that extra. So on the Stranger Things Have Happened side of the mix is when this goes into the drawing and I show that sketch, I'm going to end up with the extra center lines and the construction geometry for the for orienting the numbers. So if that's not desirable, let's go back in to the feature, and I believe nope. On one of them, I was thinking I could hide those. It might be, well, no, that would hide the whole sketch. Well, maybe stuck with those. Not exactly sure on that one. Can't really turn it into a feature because it's all open contour, single geometry. So that makes it a little bit on the difficult side. So what am I missing? I guess the only other thing we could do as a reminder would be to on the, let's see, is it going to be insert? No, I was going to say if we could find the grind marks, but still the grind marks aren't going to, well, the surface finish anyway, aren't going to be as functional in the 3D sketch or in the part. But if we want to try annotations, surface finish symbol, and we're not really given anything specific, so let's go with the surface mark. Alright, so that's kind of the problem of putting it in with the part is, well, it's not too bad. It kind of floated away, but then it came back, so yeah, we'll call that good. Alright, so we have some things to resolve when we get to the drawing side, but this gives us enough for that piece of geometry, or for that part and its geometry.